Good day, everyone. Thank you for joining me today. We will be covering the bones of the skull as well as their various foramina. Please take a special note of the contents of these foramina. Now, aside from the disclaimer you see on the screen in front of you, something to also take note of is that this tutorial serves as a summary and a teaching tool. Please remember that when you do study your anatomy, you need to constantly make reference to the objectives outlined in your yellow book. To begin, we will be looking at the bones of the skull. We will look at the foramina towards the end of this tutorial. The skull itself is comprised of 22 bones and can be divided into two portions, namely the neurocranium, which is really the brain case and covers the brain and the meninges, as well as the viscerocranium, otherwise known as the facial skeleton, and literally contains the organs for our special senses. That includes the nose, tongue, eyes, and ears. Please take note that the facial skeleton also contains the openings of the respiratory and digestive tracts, as encircled in red. We shall begin by looking at the skull from its superior aspect. Moving from the top of the page, that is to say, the anterior aspect of the skull, we have the frontal bone, the parietal bones, and the occipital bone. From there, please take note of the various sutures present on the superior aspect of the skull. Between your two parietal bones, you will see the sagittal suture. Between the parietal bones and the frontal bone, you will see the coronal suture. In the previous image, you could see both of these sutures encircled in black. The meeting point of these two sutures is known as the bregma. You will see that it's underlined and further indicated by means of an arrow here. The bregma is known as the anterior fontanelle in the skull of a newborn. The vertex is the name given to the most superior part of the skull. As we move posteriorly, we can still see the two parietal bones as well as the sagittal suture between them. We can also now see the occipital bone. The occipital and two parietal bones meet at the mastoid process of the temporal bone, a bone we will see shortly. And if you reach around to the back of your head, you will be able to feel the external protuberance of your skull, as it is quite easily palpable. At the center of this protuberance, and marked by a red X on our diagram, is the inion. At the meeting point of the parietal and occipital bones, you will find the lambdoid suture. To take it even further, the meeting point of the sagittal suture and the lambdoid suture is called the lambda, as marked by the arrow. This area is known as the posterior fontanelle in the skull of the newborn. We are now looking at the lateral aspect of the skull. Two bones we are already familiar with are the frontal and parietal bones. Take note that from this aspect, we can only see one of the two parietal bones. The other bones that we can see are the temporal and sphenoid bones, and more specifically, the greater wing of the sphenoid bone. We can also see some of the bones comprised in the viscerocranium. These include the mandible and zygomatic bone and arch. Something to take note of is that the mastoid and styloid processes are found on the temporal bone. The encircled structures indicate the sutures present on this aspect of the skull. Moving from left to right of your screen, we have the zygomaticofrontal suture, the parietotemporal suture, the parietomastoid suture, and the occipitomastoid suture. There are two more points of interest that we want to take note of when viewing the lateral aspect of the skull. The first point is the meeting point of the parietal, occipital, and mastoid process of the temporal bone. This point is known as the asterion and is known as the right and left posterolateral fontanelles in the skull of the newborn. The second point is the meeting point of the frontal, parietal, temporal, and sphenoid bones. The point itself almost forms an H shape and is known as the terion. In the skull of the newborn, it is known as the right and left anterolateral fontanelles. This point particularly is of clinical significance due to its internal relation to the anterior branch of the middle meningeal artery. Since this plate of bone is thin and thus liable to fracture, an extradural hematoma can result. We now return to the anterior aspect of the skull. As you can see, the front of the skull is incredibly detailed. We will first take note of the bones comprising the anterior aspect of the skull. Moving from top to bottom of your screen and then left to right, we have the frontal bone, the zygomatic bones, the nasal bones, the vomer, ethmoid, maxilla, and mandibular bones. A couple things to take note of is that the two nasal bones fuse to form the bridge of the nose. The hole, or opening if you will, that lies immediately inferior to these bones is known as the piriform aperture. Please take note of the fact that the zygomatic bones on either side of the skull are connected to the frontal, maxillary, and temporal bones. Please also be aware of the bones comprising the orbit or eye socket. One of the nice things with NETIS for me is its use of color and color coordination in the diagrams within, as that then makes it easier to place the bones in relation to each other, and in this case, it helps you to see more clearly the bones comprising the orbit. Now, this diagram of the frontal aspect of the skull only points out the glabella, supraorbital notch, and the orbital surface of the frontal bone. The other features of the frontal bone that you want to be taking note of is the frontal eminence, the superciliary arch, and the supraorbital margin. These three features are very closely related, so be sure to know how to distinguish between them. We are going to look very briefly at the mandible, as it is the largest and strongest bone of the face, with several noteworthy features. Looking at the image on the right-hand side of your screen, we can then see the mandible of an older individual. Note that the alveolar area is completely atrophied. This then moves the mental foramen upwards. This same foramen is below the socket for deciduous molar teeth in the neonate mandible. The first of these features is the body, with its alveolar processes for the teeth of the lower jaw. From there, also take note of the ramus. The ramus consists of the condylar process with a head, neck, and coronoid process. We've previously mentioned the mental foramen. This is also something you want to be taking note of. From there, have a look at the mandibular notch and angle. On the inner surface of the mandible, features you want to be taking note of are the mylohyoid line and mylohyoid groove, the mental spine as seen in the previous image, and the mandibular foramen. The mandibular foramen is also known as the inferior alveolar foramen. Thus far, we have been viewing the skull from an exterior perspective. We are now going to view it from an interior perspective, as there are important foramina that you need to pay attention to. Remember that foramina is the plural for foramen, an opening, usually in a bone. These foramina have very important contents that you do need to remember. Now, the slide we're currently looking at shows an inferior view of our cranial base. We are essentially looking at the roof of the mouth. This image is from Netters and is a really good image for you to use so that you may then better orient yourselves with respect to the bones of the skull. Please do be sure to familiarize yourself with it as well as is possible. For some of you, this next image may appear slightly similar to the previous image that we have just come from, while for others, it may appear completely different. We are still looking at the cranial base of the skull, but now we are looking at it from a superior aspect. This is not an area that we can readily access. However, do take note of the anterior, middle, and posterior cranial fossae. Also take note of the crista galli and the cribriform plate. The crista galli functions as an attachment point for one of the layers covering the brain. Finally, we will be looking at the foramina of the cranial base. Firstly, from an inferior aspect, and in a few moments, from a superior aspect. What you want to be taken out of this are the different foramina, as well as through which foramina the cranial nerves pass. The cranial nerves are labeled 1 through 12, but please remember to learn their actual names too. In this slide, not all of our cranial nerves are accounted for. We can see branches of cranial nerve 5. We can also see cranial nerve 7, 9, 10, 11, and 12. To take this further, we can see the mandibular branch of the trigeminal nerve, that is to say, of cranial nerve 5, and it passes through the foramen ovale. The meningeal branch of the mandibular nerve passes through the foramen spinosum. The facial nerve, which is cranial nerve 7, passes through the stylomastoid foramen. From there, do take note of the jugular fossa, as it transmits 3 cranial nerves, namely the glossopharyngeal nerve, which is cranial nerve 9, the vagus nerve, cranial nerve 10, and the accessory nerve, cranial nerve 11. We also have the hypoglossal nerve, cranial nerve 12, and it passes through the hypoglossal canal. A nice one to remember, as they do share the same name. Most, if not all of you, should be aware of the foramen magnum, as it is the most conspicuous foramen. Bordering this foramen laterally are the occipital condyles, which articulate with the atlas, the name given to the vertebra C1. Lastly, we will look at the foramina from a superior aspect. From this aspect, we can see the foramina more clearly, together with their respective contents. Working from top to bottom, we have the following. Cranial nerve 1, the olfactory nerve, being transmitted via the foramen of the cribriform plate. Cranial nerve 2, the optic nerve, being transmitted via the optic canal. From there, we then have the following 3 nerves. Cranial nerve 3, the oculomotor nerve. Cranial nerve 4, the trochlear nerve. And cranial nerve 6, the abducens nerve. These 3 nerves are all transmitted via the superior orbital fissure. Be aware of the branches of the trigeminal nerve over and above what we covered in the previous slide. Note that its maxillary branch passes through the foramen rotundum. Moving on from there, cranial nerve 7, the facial nerve, which has already been discussed. Note that superiorly, it passes through the internal acoustic meatus and inferiorly, it emerges from the stylomastoid foramen. Cranial nerve 8, the vestibulocochlear nerve, also passes through the internal acoustic meatus. Cranial nerve 9, the glossopharyngeal nerve, cranial nerve 10, the vagus nerve, and cranial nerve 11, the accessory nerve, have also been previously covered. Note that superiorly, they pass through the jugular foramen, and inferiorly, they emerge from the jugular fossa. And that brings us to the end of this tutorial. Thank you so much for your time and your attention. If you have any questions, please don't hesitate to reach out. My email address is provided below, and I do try and reply as soon as possible.